Tonight, we drift into the quietest corners of the universe. A place where time stretches, stars breathe, and galaxies move with a patience older than memory. And as you settle in, perhaps resting your head on a soft pillow or letting the room dim into darkness, you might feel something gentle, the subtle calm that comes from hearing about worlds impossibly far away. This is 100 relaxing space facts to fall asleep to, a slow, soothing journey through astronomy, cosmic history, natural wonders, and the peaceful geometry of the universe. Whether you're watching from a city filled with lights, a quiet countryside home, a dorm room, or anywhere in between, welcome. Before we begin, take a deep breath. Feel your shoulders loosen. Let the day fall away like dust drifting away from a comet tail. If you enjoy calm science, slow storytelling, or peaceful educational videos, you're welcome to like and subscribe, but only if it feels right for you. And if you wish, tell me your country, your city, and the time you're watching. I love seeing how global this relaxing community truly is. Now, let's begin our gentle ascent into the first facts of the universe, facts shaped by astronomy, physics, natural wonder, and the sheer luxury of cosmic scale. Fact 1. Space is almost a perfect vacuum, but not completely empty. Even in the deep, dark regions between galaxies, the universe holds stray atoms, dust, and whisper faint photons traveling for billions of years. Astronomers sometimes describe this emptiness as a quiet sea made of almost nothing, carrying ancient light like tiny messages from long-lost stars. When we talk about space being a vacuum, we mean that matter there is far rarer than anything on Earth, even rarer than our best laboratory vacuums. Yet, it is not truly empty. It is more like an endless, thinning field where the smallest fragments of existence wander freely. Fact 2. Stars are not scattered randomly through the cosmos. They gather in galaxies shaped by gravity. Our own home, the Milky Way, is a barred, spiral galaxy with long arms that sweep outward in elegant curves. These arms are not static. They swirl and rotate slowly over the course of hundreds of millions of years. Imagine, for a moment, a cosmic clock moving so gradually that entire eras of human history pass during just one tiny shift in a galactic arm. This slow dance creates regions dense with starbirth, while other regions drift into quieter, older darkness. Studying galaxies teaches us about cosmic structure, about the economy of matter and energy, and about the cultural stories humanity has told by looking up and charting the heavens. Fact 3. The Milky Way contains between 100 and 400 billion stars, an estimate so broad because we cannot yet see them all. Dust clouds obscure our view, and our position inside the galaxy limits what we can detect. Even so, astronomers have developed increasingly precise methods using infrared telescopes and radio data to map the hidden structures behind dense clouds of interstellar dust. These maps are like quiet, glowing atlases, expanding our sense of travel, exploration, and the technology that makes cosmic geography possible. Fact 4. Light moves at nearly 300,000 kilometers per second, yet the universe is so vast that even light needs years to cross it. When you look at the moon, you're seeing it as it was just over a second ago. When you look at the sun, you're seeing it as it was 8 minutes ago. But when you look at a distant star, you're seeing a snapshot thousands of years old, a kind of natural history woven into the sky. The light from the Andromeda galaxy shows us a view more than 2 million years old. It is the study of the past. Space turns distance into time, making every star a memory. Fact 5. The temperature of space is extremely cold, about 2.7 Kelvin, or minus 270.45 degrees Celsius. This faint warmth is the leftover glow of the Big Bang, called the cosmic microwave background. It fills the universe evenly, like the quiet after a long storm. This nearly uniform temperature tells scientists about how the early universe expanded and cooled. It also shows that space holds a subtle whisper of energy, the faintest hint of the universe's childhood. Fact 6. The moon is drifting away from Earth by about 3.8 centimeters per year. This movement is tied to tidal forces, the same gravitational tug-of-war that shapes our oceans, influences marine life cycles, and has historically guided travel, fishing, and coastal culture. As the moon slowly escapes Earth's pull, the length of our day gradually increases. Millions of years in the future, days will grow noticeably longer, though the change is so slow that no human will feel it directly. Even so, it's soothing to imagine the quiet patience of celestial mechanics at work. Fact 7. Saturn's rings are younger than the dinosaurs. For a long time, scientists believed the rings were as old as the planet itself, about 4 billion years. But recent studies suggest they may be only 100 million years old, practically new in cosmic terms. They might have formed from shattered moons or comets, broken by Saturn's tidal forces into glittering clouds of ice. When sunlight hits them, they shine like luxury ornaments floating in the darkness. Their delicate structure comes from trillions of tiny particles, each orbiting Saturn at a slightly different speed, creating the smooth, elegant bands we see through telescopes. Fact 8. Venus rotates backward. Almost every planet spins in the same direction, eastward, but Venus spins westward, meaning the sun rises in the west and sets in the east. Its rotation is also extremely slow, taking 243 Earth days to complete one spin. This strange orientation may be the result of a massive collision early in Venus's history. Today, Venus's atmosphere is thick, hot, and hostile. But its unusual rotation and glowing golden clouds make it one of the most mesmerizing worlds in astronomy. Fact 9. Neutron stars are so dense that a teaspoon of their material would weigh billions of tons. These stars form after massive stars explode in supernova, leaving behind compact remnants the size of a city. Their magnetic fields are the strongest known in the universe, and their rhythms, spinning several times per second, make them cosmic lighthouses. In a calm way, neutron stars remind us that even destruction can lead to beauty, structure, and new forms of stability. Fact 10. The observable universe is at least 93 billion light-years across. This size doesn't mean the universe is only 93 billion light-years old. Rather, space itself has been expanding while light travels. Distances stretch, galaxies drift farther apart, and the universe becomes a constantly changing landscape. The scale challenges our intuition, yet the concept is surprisingly comforting in such immensity. Our worries feel smaller, quieter, easier to release. Take another slow breath. We've only just begun. 90 more facts await, a vast sky of gentle details, cosmic wonder, and calming stories from the universe. When you imagine the universe at night, perhaps you picture stars scattered across an infinite canvas. But one of the calming truths of astronomy is that the cosmos is not random at all. It is arranged in gentle layers, quiet patterns, and structures that stretch beyond imagination, yet follow rules as elegant and soothing as the rhythm of the tides on Earth. Tonight, as we drift a little deeper into our relaxing journey through space, let us explore the way the universe arranges itself, softly, almost like a natural lullaby formed over billions of years. Fact 4 is a beautiful starting point. The universe has a structure much like a cosmic web. Galaxies don't float alone in total emptiness. They gather in clusters and superclusters connected by long filaments of dark matter and gas. These filaments stretch for millions of light years, giving the universe a delicate and lace-like form. Even though the scale is enormous, the behavior is gentle. Gravity nudges galaxies toward these filaments, guiding them gradually over billions of years out, creating a cosmic pattern that feels as natural as rivers flowing toward the sea. Fact 5. The largest known structure in the observable universe is the Hercules Corona Borealis Great Wall, a massive assembly of galaxies spanning more than 10 billion light-years. It's so vast that light itself, moving at 300,000 kilometers per second, would take 1/10 the age of the universe to cross it. Yet even this titan of space was not formed rapidly or explosively. It accumulated slowly, the way mountains rise on Earth over eras too long for any one lifetime to notice. Its existence reminds us that the universe grows with patience, not urgency, a theme perfect for soothing late-night thoughts. Fact 6 carries us deeper into the structure of galaxies themselves. Our home galaxy, the Milky Way, is a barred spiral galaxy with several elegant arms that swirl outward from a central bar-shaped cluster of stars. These arms aren't solid structures. They're more like slow-moving waves. Stars drift through them over millions of years. The arms appear brighter because more stars are present in these regions, but they do not rotate in perfect unison. This wave-like behavior, called density wave theory, creates a cosmic version of traffic patterns, except the traffic jams last hundreds of millions of years. Nothing about it is rushed. If you look up into the night and imagine the structure of our galaxy, you might picture our solar system near the center. But fact 7 gives us a calmer, more comforting truth. We live far from the dangerous, energetic core, safely tucked away in one of the quiet, spiral arms known as the Orion Arm, or sometimes the Orion Spur. This location protects Earth from intense radiation, supermassive black hole activity, and the highest concentrations of explosive stars. The universe has placed us in a tranquil suburb, ideal for life and long-term stability. Fact 8 brings us to the idea that galaxies themselves aren't scattered randomly. The Milky Way is part of a small collection of galaxies called the Local Group, a cluster with just over 50 known members. The Andromeda Galaxy is the largest, and although it is drifting toward us, there's nothing chaotic or frightening about this movement. The two galaxies are expected to merge in about 4.5 billion years, a slow waltz choreographed by gravity. When they do meet, most stars will pass by each other without ever colliding. Space is too vast, and stars are too widely spaced. Even during a galactic merger, the universe remains serene. Fact 9 takes us beyond our local group to the Laniakea supercluster, a region that includes tens of thousands of galaxies, all gently flowing toward a gravitational center known as the Great Attractor. This supercluster is so large that if we tried to travel across it at the speed of light, the journey would take about 500 million years. Yet the galaxies within Laniakea drift at a pace so slow that their movement is imperceptible over a human lifetime. The cosmic choreography is patient, never hurried. Fact 10 invites us to consider dark matter, a mysterious form of matter that does not emit light, but shapes galaxies with its gravitational presence. Dark matter makes up roughly 27% of the universe, yet we cannot see it directly. The only reason we know it exists is because galaxies rotate too quickly to be held together by visible matter alone. Dark matter acts as a gentle but invisible scaffold, keeping galaxies stable and preventing stars from flinging outward into deep space. Even the unseen components of the universe work quietly, supporting the cosmic architecture with subtle influence rather than force. Fact 11 offers a calming perspective on dark energy, which makes up about 68% of the universe and is responsible for its accelerating expansion. Rather than slowing down, the universe is stretching faster and faster over time. This expansion happens uniformly and peacefully across space. No sound, no turbulence, just a smooth, silent widening of the cosmic fabric. If you imagine the universe as a soft blanket being pulled outward in all directions evenly, you have the right idea. Dark energy ensures that galaxies grow farther apart, maintaining the quiet darkness between them. Fact 12 brings us to the cosmic microwave background, often called the afterglow of the Big Bang. This faint radiation fills the universe uniformly and provides a snapshot of what the cosmos looked like just 380,000 years after its beginning. In astronomy terms, that is a newborn universe. The cosmic microwave background is extremely smooth, with tiny temperature variations that reveal early structures forming in the infant cosmos. It is one of science's most poetic discoveries, a soft, ancient whisper preserved across all of space. Fact 13 turns our attention to galaxy shapes. While spiral galaxies like the Milky Way are beautiful, calm spirals of stars, elliptical galaxies are large, rounded, and often contain older stars. They have less gas and dust, which means fewer new stars are formed. This gives elliptical galaxies a peaceful, settled feel, like cosmic retirement homes where stars age gracefully. Irregular galaxies, by contrast, have no defined shape and sometimes result from past mergers or gravitational distortions. They are reminders that even in the most peaceful universe, gentle variations create diversity and wonder. Fact 14 highlights something subtle about galaxies. Their colors reflect their age and behavior. Blue galaxies are actively forming new stars. Red galaxies, however, have mostly older, cooler stars. If you imagine drifting through space, a red galaxy might feel like a warm, quiet place where time has slowed down, while a blue galaxy would feel youthful and energetic. Fact 15 brings us full circle to our cosmic neighborhood. The nearest major galaxy to the Milky Way, Andromeda, is visible from Earth with the naked eye under dark skies. You are seeing light that left that galaxy more than 2.5 million years ago, long before humans walked the Earth. Even the light we see from distant galaxies arrives slowly, quietly, carrying with it the memory of a universe that existed long before our world began. As we close this part of the video, let these facts settle in your mind like soft starlight. The cosmos is enormous, yet gentle, vast, yet organized. It moves not with chaos, but with patience. And in that patience, there is a kind of peace that makes it perfect for calming, late-night reflection. In the silence of night, when the sky opens like a velvet curtain, the stars become gentle companions. They glow softly, each one a distant sun, each one a reminder that the universe is alive with calm and ancient rhythms. As we drift deeper into this peaceful journey, the focus turns toward the stars themselves. How they are born, how they live, and how they fade, all in cycles that unfold so slowly and gracefully that they feel like cosmic lullabies. Fact 16 invites us to begin at the very beginning of a star's life, the giant molecular cloud. These clouds, sometimes called stellar nurseries, are enormous gatherings of gas and dust where gravity starts its gentle pull, causing some regions to become denser over time. Stars are not born in an instant. They form slowly over millions of years as the gas gradually collapses under its own weight. As a cloud tightens, it warms, soft light begins to emerge, and eventually a new star glows into existence. Even the most brilliant stars begin their lives quietly in darkness before ever shining. Fact 17 brings us to the main sequence stage, the long and stable period where a star spends most of its existence. For a star like our Sun, this phase lasts about 10 billion years. Main sequence stars are like the calm adults of the universe, stable, reliable, and providing warmth and light without dramatic change. When we look up at night, most of the stars we see are in this tranquil part of their life cycle. Fact 18 reminds us that not all stars shine with the same color or brightness. A star's color reveals its temperature. Blue stars are incredibly hot and young, burning their fuel quickly. Red stars are cooler and often older. Our Sun sits in the middle, glowing yellow-white, with a temperature that supports life on Earth. If you could drift across the galaxy, passing from blue hot giants to soft red dwarfs, it would feel like moving through different shades of cosmic warmth, each one marking another type of stellar personality. Fact 19 offers a calming truth. Red dwarf stars, the smallest and coolest stars, are also the most common in the universe. They burn their fuel so slowly that they can live for trillions of years, far longer than the current age of the universe. These stars represent longevity and stability. If future civilizations ever look for peaceful havens in deep space, red dwarfs may be among the first places they examine. Their calm endurance is unmatched. Fact 20 brings us to supergiants, some of the most luminous stars known. Despite their brilliance, their lives are not as long. They burn intensely, live fast, and end dramatically. Yet, even their endings play an essential role in the universe. When a massive star dies, it enriches the galaxy with heavy elements like carbon, oxygen, and iron, the elements needed for planets, oceans, and even life. This is one of astronomy's most comforting ideas. Every atom in the human body was forged in a star long before Earth existed. We carry starlight in our bones. Fact 21 lets us focus on the Sun itself, our life-giving star. The Sun is about halfway through its 10 billion year main sequence lifespan. Its light takes 8 minutes to reach Earth, traveling through space in silence. Even though it feels eternal, the Sun is constantly changing. Its magnetic activity rises and falls in cycles of about 11 years, creating sunspots, solar winds, and gentle fluctuations in energy output. These natural variations are delicate and rhythmic, like the breathing of a sleeping giant. Fact 22 leads us to the understanding that stars do not shine indefinitely. When a star like our Sun runs out of hydrogen, it begins to fuse helium and grows into a red giant. During this stage, the outer layers slowly swell outward. The process is not violent, it's gradual and majestic, unfolding over millions of years. Eventually, the outer layers drift into space, forming a glowing shell of gas called a planetary nebula. At the center, what remains is a small, dense white dwarf, the cooling core of the former star, gently dimming over billions of years. Fact 23 brings us to neutron stars, one of the universe's most astonishing creations. When very massive stars end their lives in supernova explosions, their cores collapse into objects so dense that a teaspoon of their matter would weigh billions of tons. Despite this incredible density, neutron stars are tiny, often no wider than a city. They spin rapidly, sometimes hundreds of times per second, and emit beams of radiation that sweep across space like distant lighthouses. Yet, despite their intensity, neutron stars exist silently, with no sound in the vacuum of space. Fact 24 explores one of the most calming concepts in astronomy. The light we see from stars is old. Some stars, visible tonight, shine with light that began its journey hundreds or thousands of years ago. In the case of distant galaxies, the light we observe left them millions of years in the past. When you look at the night sky, you are seeing messages from long before modern history, long before human civilization, even long before many species on Earth existed. The stars are storytellers of ancient eras. Fact 25 brings us to variable stars, which change in brightness over time. One famous example is Cepheid variable stars, which pulse regularly. These stars act as cosmic distance markers, helping astronomers measure how far away galaxies are. The universe has gifted us natural beacons, calm, predictable, and incredibly valuable, that allow humanity to understand the scale of existence. Fact 26 offers a soothing insight into binary stars. Many stars in the universe are not alone, like the Sun. Instead, they exist in pairs or even trios, orbiting each other in elegant, slow loops. Some of these systems take decades or even centuries to complete a single orbit. Their movement is gravitational choreography, gentle, balanced, and steady. If you could watch a binary system over thousands of years, the view would feel like a cosmic dance. Fact 27 invites us to consider the rare but fascinating phenomenon of runaway stars. These are stars that move at unusually high speed through the galaxy, often due to gravitational interactions that sent them flying. Despite their speed, they glide silently through the darkness, leaving behind faint traces detectable only through careful observation. Even the swiftest travelers of the galaxy move in quiet dignity. Fact 28 brings attention to brown dwarfs, often called failed stars. They are not massive enough to sustain hydrogen fusion, so they never ignite like true stars. Instead, they glow faintly with residual heat, fading slowly over time. Brown dwarfs live in the quiet spaces between stars and planets, gentle reminders that the universe contains objects that exist in between categories, peaceful, subtle, and often overlooked. Fact 29 deepens the sense of cosmic connection. Astronomers estimate that there are at least 100 billion stars in the Milky Way alone, and possibly trillions of galaxies across the universe. The total number of stars may exceed all grains of sand on Earth. Yet, despite this unthinkable scale, each star follows the same simple rules of physics. There is harmony in the repetition, a cosmic pattern that repeats across unfathomable distances. Fact 30 closes this part with a serene thought. Even though stars live for millions or billions of years, their existence is part of a continuous, unbroken cycle. New stars form as old ones fade. The elements from ancient stars gather and create new solar systems, and somewhere, eventually, planets form. Oceans may appear. Life may begin. The universe is not just vast. It is purposeful, gentle, and infinitely patient. When you next look up at the night sky, you are seeing the quiet heartbeat of the cosmos, steady, luminous, and eternal. When you imagine drifting deeper into the night sky, past the soft glow of individual stars, you eventually arrive at a much grander scale, galaxies. These vast, island-like structures float across the universe, each one containing billions or even trillions of stars. They move, evolve, and interact over time scales so long that their motions resemble slow tides rather than anything abrupt or forceful. As we continue into our quiet exploration of space, galaxies offer some of the most soothing and awe-inspiring facts. Fact 31 begins with a simple understanding that a galaxy is an immense collection of stars, gas, dust, and dark matter, all held together by gravity. The word galaxy comes from the Greek galaxias, meaning milky, a reference to the band of soft light we see across our night sky, the Milky Way. When ancient civilizations looked upward, they saw a milky river painted across the heavens. Only much later did humanity realize it was not a single feature, but our entire home galaxy seen from within. Fact 32 tells us that the Milky Way is a barred spiral galaxy, meaning that at its center is a bar-shaped cluster of stars from which graceful, curling arms extend outward. These spiral arms sweep across space in subtle arcs, each one hosting clouds where new stars are continuously born. Although models often show the Milky Way spinning quickly, the reality is slow and elegant. One full rotation of the galaxy takes about 230 million years. Imagine Earth traveling through the galaxy like a calm passenger on a silent journey, moving around the center at a pace that spans entire eras of life on our planet. Fact 33 invites you to picture our galactic neighborhood. The Milky Way is part of the Local Group, a small cluster of more than 50 galaxies. The two most famous companions are the Large Magellanic Cloud and the Small Magellanic Cloud, visible from the southern hemisphere. These galaxies are irregular in shape, almost like cosmic brushstrokes on the sky, and they orbit the Milky Way slowly over billions of years. These neighboring galaxies add depth and quiet companionship to our place in the cosmos. Fact 34 introduces the Andromeda Galaxy, the Milky Way's largest nearby neighbor. Andromeda is a spiral galaxy, roughly twice the size of ours, located about 2.5 million light-years away. Its light takes so long to reach us that when you see it with a naked eye, you are gazing into the distant past. Andromeda and the Milky Way are slowly drifting toward each other and will eventually merge in about 4 to 5 billion years. This collision sounds dramatic, but because galaxies are mostly empty space, the process will be more like a gentle overlapping of star systems and clouds, unfolding over billions of years. It will be a cosmic blending, not an explosion. Unlike spirals, which have beautiful structure, elliptical galaxies are smooth, rounded, and often contain older stars. They lack the bright, star-forming regions found in spiral arms. These galaxies are like quiet retirement homes of the universe, where stars that formed long ago continue their slow, tranquil aging. Ellipticals are common in galaxy clusters, where interactions between galaxies tend to disrupt spiral structures over time. Fact 36 highlights irregular galaxies, those that defy simple classification. These galaxies often appear chaotic or asymmetrical, shaped by past encounters with neighbors or by the internal movement of gas. Irregular galaxies remind us that not all structures in the universe follow neat patterns. Some grow and evolve through turbulence and randomness, yet they still form stars, create planets, and participate in the same cosmic cycles shared by all galaxies. Fact 37 focuses on dwarf galaxies, the smallest and most numerous type in the universe. Some dwarfs contain only a few million stars, a tiny number compared to the Milky Way's hundreds of billions. These galaxies orbit larger ones, often acting like quiet companions. The Milky Way itself has several dwarf galaxies, slowly merging into it. This gradual merging is one of the ways big galaxies grow, not through sudden events, but through gentle, slow accumulation over cosmic time. Fact 38 brings us to one of the most mysterious aspects of galaxies: dark matter. Scientists estimate that visible matter, stars, planets, gas, makes up only a small fraction of a galaxy's total mass. The rest is dark matter, an invisible substance detected only through its gravitational effects. Dark matter acts like a silent framework that holds galaxies together. Without it, galaxies would not rotate as slowly and gently as they do. Their stars would fly apart. Dark matter binds the cosmic tapestry with quiet strength, unseen but essential. Fact 39 introduces the concept of supermassive black holes, which sit at the center of most large galaxies, including the Milky Way. Our galaxy's central black hole is called Sagittarius A*, and although it has a mass about 4 million times that of the Sun, it is surprisingly calm. It does not constantly devour matter. Most of the time, it simply exists as a dark anchor at the galaxy's core, influencing the motion of nearby stars. Even something as powerful as a black hole can be peaceful when observed across long stretches of time. Fact 40 brings us to galaxy clusters, some of the largest structures in the universe. A single cluster can contain hundreds or thousands of galaxies bound together by gravity. Within these clusters lies hot gas that emits X-rays and vast amounts of dark matter that hold everything in balance. Clusters drift through space like giant families of galaxies, each member continuing its own internal evolution while still part of the larger group. Fact 41 looks at the Virgo cluster, the nearest large galaxy cluster to the Milky Way. It is located about 54 million light-years away and contains more than 1,000 galaxies. Our local group is slowly moving toward the Virgo cluster due to gravitational attraction. But the movement is so gradual that even over millions of years, the distance decreases only slightly. On the scale of galaxies, motion feels like a gentle drift, not a rush. Fact 42 introduces galaxy filaments, the largest known structures in the universe. These filaments are vast networks of galaxies and gas that stretch across hundreds of millions of light-years, forming webs that outline the shape of the cosmos. Between them lie enormous voids, spaces with almost no galaxies at all. This cosmic web forms a pattern that is surprisingly delicate. If you could view it from above, the universe would look like a lacework of light. Fact 43 highlights one of the calming truths about galaxies. The overwhelming majority of the universe is empty. Even inside galaxies, stars are incredibly far apart. If the Sun were the size of a grain of sand, the next nearest star would be the distance of several football fields away. This immense spacing means that even when galaxies collide, stars almost never hit each other. Space is peaceful, not because nothing moves, but because everything moves with room to breathe. Fact 44 explores starburst galaxies, where rapid star formation occurs. These galaxies are relatively rare and create stars at rates far higher than normal. Even so, starburst periods last only a short time in cosmic terms. They are bursts of creativity, brief moments when a galaxy glows with new life before settling back into a quieter rhythm. Nature, even on the scale of galaxies, seems to balance activity with rest. Fact 45 draws attention to the observable universe itself. Based on current measurements, it stretches about 93 billion light-years across. This number does not represent the entire universe, only the part we can see. Beyond that, the cosmos continues, possibly infinitely. The idea that galaxies fill this vast space in every direction offers a humbling sense of calm. No matter where you look, there are structures gently drifting, forming, and dissolving. Fact 46 brings us to gravitational lensing. Sometimes, a galaxy or cluster of galaxies bends the light of more distant objects behind it. This bending, caused by mass curving spacetime, creates arcs, rings, or distorted shapes. The effect is beautiful, like a natural magnifying glass, sculpting light into delicate forms. Gravitational lensing is one of astronomy's most serene phenomena. A gentle reminder that light itself can follow curved paths. Fact 47 considers the age of galaxies. Most galaxies formed not long after the universe began, about 13.8 billion years ago. Over time, they grew as stars formed and gas clouds merged. Some galaxies we observe today appear exactly as they were billions of years ago, their light only now arriving. When astronomers look into deep space, they are seeing ancient objects exactly as they appeared during the universe's eras. It is like having a window into cosmic history. Fact 48 offers a soothing insight into the future of the Milky Way when it merges with Andromeda. The result will likely be a large elliptical galaxy, often nicknamed Milk-Dromeda. The process will take billions of years and unfold slowly, with stars drifting past one another in quiet streams. The night sky of future Earth, or whatever world may exist by then, will glow with graceful arcs of stars as both galaxies blend. Fact 49 reminds us that galaxies recycle material constantly. Old stars shed their outer layers, creating gas clouds. These clouds form new stars. Supernova explosions enrich the gas with heavy elements. The cycle continues endlessly, a natural renewal process that gives the universe its structure. Galaxies are not static. They are living systems with long, slow rhythms. Fact 50 brings this part to a calm conclusion. Despite their size and complexity, galaxies are governed by simple rules: gravity, motion, and time. These forces shape billions of stars into elegant patterns. They draw galaxies together and gently pull them apart. They create harmony across distances so vast that human imagination can barely grasp them. In every spiral arm and every glowing cluster, the universe expresses its quiet balance, a balance that continues even when no one is watching. When you think of galaxies, imagine islands of starlight adrift in a peaceful sea, each one glowing softly in a universe that moves at the pace of eternity. As we drift deeper into the soft darkness of space, the next natural place to rest our attention is on the stars themselves. They seem small from afar, tiny shining points scattered across the night, yet each one is a colossal sphere of glowing plasma, balancing the forces of gravity and nuclear fusion in a cosmic dance that lasts millions, billions, or even trillions of years. This part invites you to imagine stars not as distant objects, but as calm, steady light that shape the quiet architecture of the universe. Fact 51 begins with a fundamental truth. Stars are born inside clouds of gas and dust, places sometimes called stellar nurseries. These regions are often large, cold, and dark, filled with hydrogen that drifts softly until gravity pulls it inward. When enough gas gathers in one place, pressure grows, temperatures rise, and a new star ignites. The process happens slowly, over millions of years, like a deep inhale before a quiet, glowing exhale. Every star you see began as a fragile swirl in a calm, cosmic cloud. Fact 52 brings us to the life cycle of stars. Despite their enormous size, stars live predictable lives guided by mass. Low-mass stars burn their fuel slowly and can remain stable for tens of billions of years. High-mass stars burn brightly and briefly, lasting only a few million years. This relationship between mass and lifespan means that the dimmest stars are often the most enduring. Red dwarfs, the smallest stars, shine so efficiently that many existing today will outlive the universe as we currently understand it. Fact 53 explains what makes stars shine. At their cores, nuclear fusion transforms hydrogen into helium, releasing energy in the form of light and heat. This fusion counteracts gravity, preventing the star from collapsing. Imagine this process like a calm heartbeat, steady, balanced, and continuous. For most of a star's life, this balance remains undisturbed, giving stars their gentle, steady glow. Fact 54 reminds us that the Sun is a star. It appears larger and brighter because it is much closer than any other star, but in many ways, it is quite ordinary. Classified as a G-type main sequence star, the Sun sits in a peaceful phase of its life. It has been shining for about 4.6 billion years and will continue for roughly 5 billion more. The Sun's slow evolution creates stability for Earth, shaping climates, seasons, and life in a way that feels both comforting and predictable. Fact 55 offers insight into the color of stars. Blue stars are the hottest. White stars, slightly cooler. Yellow stars, like the Sun, in a comfortable mid-range. And red stars, the coolest. When you look up, the colors may blend together. But through a telescope or long exposure photography, the night sky reveals a quiet rainbow. Each hue is a reflection of a star's energy and age, adding to the serene complexity of the universe. Fact 56 introduces one of the most calming thoughts in astronomy. Stars twinkle because of Earth's atmosphere. When starlight reaches us, it passes through layers of air that shift slightly due to temperature and movement. This bending makes the light appear to flicker. The stars themselves do not change. It is simply the atmosphere adding a gentle shimmer. For planets, which appear larger in the sky, the effect is less noticeable, which is why planets shine more steadily. Fact 57 brings attention to binary and multiple star systems. Many stars are not solitary like the Sun. Instead, they orbit one or more partners in slow, graceful patterns. Some pairs revolve tightly, completing an orbit in days. Others drift far apart, taking centuries or millennia to circle each other. Their interactions remind us that even stars experience companionship, moving around shared centers with quiet predictability. Fact 58 introduces variable stars, stars that change in brightness over time. Some pulsate gently, expanding and contracting like a cosmic breath. Others brighten and dim due to interactions with companion stars. These cycles can be regular or irregular, fast or slow. Although variability might seem like instability, many variable stars follow patterns that are remarkably steady, making them useful tools for measuring distances across the universe. Fact 59 invites us to consider giant stars. As stars exhaust their hydrogen fuel, they expand. A star, like the Sun, will eventually grow into a red giant, swelling until it engulfs the region where Mercury and Venus once orbited. This phase is both dramatic and gentle, unfolding over millions of years. The outer layers drift away into space, forming beautiful clouds called planetary nebulae. These glowing shells are among the most peaceful phenomena in the cosmos, delicate, colorful, and slowly expanding. Fact 60 brings us to supergiants, the largest stars in the universe. Stars like Betelgeuse and Rigel are thousands of times brighter than the Sun and have radii hundreds of times larger. Yet, despite their enormous size, their lives are short. They burn intensely, exhausting their fuel quickly. When they reach the end of their lives, they often explode as supernova, releasing elements that eventually become part of new stars, planets, and even life. This cycle of creation and transformation is one of the universe's most beautiful rhythms. Fact 61 explores white dwarfs, the remnants of stars that were once like the Sun. After shedding their outer layers, these stars leave behind a hot, dense core that no longer fuses elements but continues glowing for billions of years as it cools. White dwarfs are stable, silent, and faint cosmic embers lingering long after their active life ends. Over unimaginable spans of time, they slowly fade into black dwarfs, though the universe is not old enough for any to have formed yet. Fact 62 looks at neutron stars, which form when massive stars collapse under gravity after a supernova. These stars are so dense that a teaspoon of their material would weigh billions of tons. Despite their extreme properties, neutron stars are typically small, only about 20 kilometers across. Some rotate rapidly, emitting beams of radiation like cosmic lighthouses. Their steady pulses are some of the most regular patterns known in nature. Fact 63 introduces magnetars, a rare type of neutron star with incredibly strong magnetic fields. These fields can be 1 trillion times stronger than Earth's. Although magnetars occasionally release bursts of energy, most of the time they simply drift in space, quietly spinning, their magnetic forces contained within. Even the universe's most intense objects can exist in long periods of stillness. Fact 64 invites you to imagine brown dwarfs, objects too large to be planets, but too small to sustain full hydrogen fusion. They glow faintly, emitting heat and infrared light, but never igniting into full stars. Often called failed stars, they are better thought of as transitional objects existing in a peaceful middle ground. Brown dwarfs drift quietly through space, radiating softly for billions of years. Fact 65 offers a gentle perspective on starlight itself. When you look at the night sky, you are seeing the past. Light from nearby stars may be several years old. Light from more distant stars may be centuries or millennia old. The night sky is a collection of memories, messages, traveling silently across space to reach your eyes. This sense of connection across time is one of the soothing wonders of astronomy. Fact 66 returns us to clusters of stars. Many stars form in groups, emerging from the same clouds. These clusters can be open or globular. Open clusters are loosely bound, often containing young stars that eventually drift apart. Globular clusters are dense, spherical collections of hundreds of thousands of old stars. Fact 67 looks at star-forming regions such as the Orion Nebula. These glowing clouds are laboratories of creation, where young stars illuminate the gas around them. Viewed through telescopes, they reveal intricate shapes, tendrils, bubbles, and filaments sculpted by radiation and gravity. The light from these regions travels across hundreds or thousands of light years, carrying the soft glow of newborn stars. Fact 68 explores the idea that stars create the elements. The carbon in your body, the oxygen you breathe, the calcium in your bones, all formed inside stars or during supernova explosions. When stars die, they release these elements into space, where they become part of new systems. This process of enrichment means that every living being is connected to the life cycles of ancient stars. The universe is not distant. It is part of us. Fact 69 highlights the calm predictability of stellar evolution. For all their variety, stars follow clear paths determined by mass and composition. Astronomers can model their behavior with remarkable accuracy. This reliability gives stars a sense of rhythm, like celestial clocks ticking across billions of years. Fact 70 completes this part with a tranquil truth. Stars do not rush. Their births, lives, and deaths unfold over such long timescales that even the most dramatic events feel gentle when viewed at cosmic speed. They shine steadily, age quietly, and transform gradually. In their light, the universe feels timeless. As we gently move farther from the familiar glow of individual stars, the universe widens into breathtaking structures that hold billions and sometimes trillions of suns. Galaxies stretch across space like peaceful archipelagos, each one a collection of stars, dust, gas, and dark matter bound together by gravity. In this part, you can imagine yourself gliding slowly among them, letting their shapes, colors, and histories unfold with the same calm rhythm that guides the night sky. Fact 71 reminds us that galaxies come in a variety of shapes. Some are elegant spirals, their arms curling outward like soft, swirling brushstrokes. Others are smooth ellipses, glowing like hazy lanterns suspended in space. There are also irregular galaxies whose shapes have been sculpted by gravitational encounters. These differences tell a story of formation, evolution, and quiet cosmic interactions. Spiral galaxies often contain younger, bluer stars in their arms, while elliptical galaxies typically house older, redder stars. Irregular galaxies, meanwhile, resemble scattered collections of celestial ink. Freeform and beautiful in their unpredictability. Fact 72 introduces the Milky Way, the galaxy you call home. From inside, it appears as a faint, milky band stretching across the night sky, made of countless unresolved stars. But if you could see it from far away, it would appear as a barred spiral with sweeping arms that extend outward from a glowing central bar. The Milky Way spans around 100,000 light-years, and its calm rotation takes more than 200 million years to complete a single turn. Everything you've ever known, Earth, the Sun, every star you've seen, is part of this vast, gently turning structure. Fact 73 reveals that the Milky Way contains around 200 to 400 billion stars, though the exact number is difficult to determine because of dust and distance. This staggering population creates a sense of richness and depth. The night sky is only a small sampling of this cosmic city, a few lights from nearby neighborhoods. Beyond them stretches an entire metropolis of stars, each with its own story. Fact 74 shifts focus to Andromeda, the nearest large galaxy to the Milky Way. It lies about 2.5 million light-years away, yet it is still visible to the naked eye in dark skies as a faint smudge. Andromeda is slightly larger than the Milky Way and contains roughly 1 trillion stars. Despite this immense scale, its light is peaceful and understated. And in the far future, about 4 to 5 billion years from now, the Milky Way and Andromeda will merge, forming a new galaxy. The process will unfold slowly, gracefully, over billions of years, with most stars passing by one another without ever colliding. Fact 75 continues this thought by explaining that galaxy mergers are common and natural. When two galaxies draw close, gravity stretches and distorts them, creating long, trailing streams of stars called tidal tails. These interactions can spark star formation as clouds of gas compress. Far from being chaotic, the process often leads to new structures and renewed vitality. The universe reshapes itself with a kind of patient creativity. Fact 76 looks at dwarf galaxies, the smaller companions of giant galaxies like the Milky Way. Dwarf galaxies contain anywhere from a few million to several billion stars. Though small, they play crucial roles. Many orbit larger galaxies, contributing stars and gas over time. The Milky Way alone has dozens of dwarf galaxies surrounding it, including the Sagittarius dwarf and the Large and Small Magellanic Clouds, visible from the southern hemisphere as glowing patches of light. These galaxies feel like gentle companions traveling alongside our own. Fact 77 touches on the Large Magellanic Cloud, a dwarf, irregular galaxy about 160,000 light-years away. Despite its size compared to the Milky Way, it is still full of activity and features the Tarantula Nebula, one of the most vigorous star-forming regions nearby. This nebula glows with young stars, gas, and dust, creating a landscape of bright knots and swirling patterns. Even small galaxies can host enormous wonders. Fact 78 moves to the Small Magellanic Cloud, about 200,000 light-years away. It contains younger star clusters and regions still rich in gas. Both Magellanic Clouds are thought to be interacting with the Milky Way, slowly influenced by its gravity. These quiet interactions shape their evolution, adding gentle complexity to their motions and star formation processes. Fact 79 expands our view to galaxy clusters, groups of galaxies bound together by gravity. The Virgo cluster, for instance, contains over 1,000 galaxies. Such clusters are enormous, often stretching millions of light-years across. They form some of the largest structures in the universe. Within them, galaxies drift slowly around a common center, creating the impression of a vast cosmic city with neighborhoods of spiral, elliptical, and irregular galaxies. Fact 80 describes superclusters, even larger structures made of multiple galaxy clusters. The Milky Way is part of the Laniakea supercluster, a vast network of galaxies flowing toward a gravitational center called the Great Attractor. Laniakea extends over 500 million light-years and contains around 100,000 galaxies. Yet despite this enormous scale, motion within the supercluster is smooth and gentle, like currents in a quiet ocean. Fact 81 introduces the idea that galaxies are mostly made of dark matter, an invisible form of mass that does not emit or absorb light. Astronomers detect dark matter through its gravitational effects, such as the speed at which stars orbit within galaxies. Without dark matter, galaxies would not hold together. This mysterious substance acts like a cosmic framework, shaping galaxies while remaining unseen. Its presence adds a layer of quiet wonder to our understanding of the universe. Fact 82 explains that galaxies rotate. Stars near the center orbit faster than those farther out, but overall, the rotation is surprisingly uniform. Another clue pointing to the presence of dark matter. The Milky Way's rotation speed at the Sun's position is about 220 kilometers per second, yet we feel nothing. Gravity moves us along effortlessly, and the galaxy's slow spin becomes a kind of cosmic lullaby. Fact 83 brings us to starburst galaxies. These are galaxies experiencing a surge in star formation. Gas clouds collapse rapidly, forming new stars at rates far higher than usual. The cause is often interactions or mergers with other galaxies. Even though starburst activity is energetic, it is not chaotic to outside observers. The galaxy simply glows brighter, with newborn stars illuminating the gas around them. Fact 84 touches on lenticular galaxies, which exist between spirals and ellipticals. They have a central bulge and a disk, but lacks spiral arms. Lenticular galaxies offer a tranquil balance, structured yet smooth, shaped by time and past interactions. They may have used up most of their star-forming gas, leaving behind stable populations of older stars. Fact 85 highlights that galaxies evolve. A spiral may become an elliptical after a merger. A dwarf galaxy may be absorbed by a larger one. Over billions of years, galaxies shift their shapes, change their activity levels, and acquire new populations of stars. These transformations are slow and subtle, reinforcing the idea that the universe is never static, yet never hurried. Fact 86 reveals that galaxies produce beautiful jets of energy when material falls into central supermassive black holes. These jets stretch thousands or even millions of light years. Although they sound dramatic, from afar they appear as slender beams of radio, X-ray, or visible light. The jets themselves are stable, focused, and elegant, like distant cosmic beacons. Fact 87 looks at barred spiral galaxies which have a bright bar of stars cutting through their centers. The Milky Way is one of these. Bars help funnel gas toward the core, influencing star formation. The shape adds a sense of structure, a kind of quiet architectural detail in the galaxy's design. Fact 88 invites you to imagine ultra-diffuse galaxies spread out so widely that they appear ghostly and faint. These galaxies can be as large as the Milky Way, but contain far fewer stars. Some are dominated by dark matter, while others contain surprisingly little of it. They float through space like barely visible whispers. Fact 89 highlights the concept of galaxy filaments, the enormous threads that form the cosmic web. These filaments link clusters and superclusters, shaping the universe into vast, interconnected structures. Between them lie enormous voids, regions with few galaxies. This web-like architecture creates a calming pattern, like gentle stitching across the universe. Fact 90 closes this segment with a peaceful realization. Galaxies are not merely distant places. They are homes for stars, planets, nebulae, and possibly life. They move, evolve, and interact with one another in rhythms far slower than anything on Earth. When viewed with patience, galaxies feel less like chaotic swirls and more like serene islands, drifting through an ocean of space with quiet grace. Nebulae are among the most tranquil sights in the universe. Vast clouds of gas and dust that drift like gentle mist across the darkness. Their colors, shapes, and glowing textures give the cosmos as if the universe itself pauses to inhale and exhale around them. In this part, we drift through these celestial clouds, letting their calm presence deepen the stillness of the night. Fact 91 introduces the central idea. Nebulae are stellar nurseries. They are the birthplaces of stars where gas and dust slowly collapse under gravity to produce new light. This process takes millions of years, unfolding with a patience that seems tailored for quiet reflection. Within these clouds, future stars begin as small clumps of material, gradually growing until the pressure in their cores becomes intense enough to ignite nuclear fusion. When they do, they shine gently into the surrounding cloud, illuminating it from within. Fact 92 brings us to the Orion Nebula, one of the brightest and closest star-forming regions to Earth. Located about 1,344 light-years away, it glows with soft purples, reds, and blues when captured in long-exposure images. To the naked eye, it appears as a faint patch in Orion's sword, but through a telescope, it becomes a shimmering cloud with newborn stars nestled inside. The Orion Nebula is home to the Trapezium Cluster, a group of young hot stars whose light carves delicate shapes and shadows into the surrounding gas. The entire region looks like a cosmic cradle, lit by flickering newborn suns. Fact 93 turns to the Eagle Nebula and its famous pillars of creation. These towering structures of gas stretch across several light-years and were photographed with remarkable detail by the Hubble Space Telescope. The pillars glow softly, eroded by ultraviolet radiation from young stars. Within them, pockets of denser gas collapse to form more stars. The scene feels both grand and serene, like a mountain range made of vapor illuminated by distant lanterns. Fact 94 explores reflection nebulae. These clouds do not produce their own light. Instead, they reflect the glow of nearby stars. Their color is often a soft blue because dust scatters blue light more efficiently than red light. Reflection nebulae appear as faint shimmering clouds that seem to hold starlight gently, the way mist near a street lamp glows softly at night. Fact 95 shifts to a meso nebulae, which glow because their gas is energized by the radiation of nearby stars. The gas emits specific colors, often shades of red or pink, due to ionized hydrogen. These nebulae are among the most colorful regions of space, but even their vivid hues feel calm when viewed through long exposures. They resemble slow-moving flames suspended in time. Fact 96 introduces planetary nebulae, the final breath of dying, sun-like stars. When these stars exhaust their fuel, they shed their outer layers, forming delicate shells of gas that expand outward. At the center, the fading star glows hot, illuminating the material it once held close. Planetary nebulae come in intricate shapes: rings, bubbles, hourglasses, and spirals. The ring nebula in Lyra, for instance, appears as a glowing blue and red donut, its colors soft and dreamlike. Fact 97 focuses on the Helix Nebula, sometimes called the Eye of the Universe. Located about 650 light-years away, it resembles a giant, luminous eye gazing serenely into space. Its layered rings of gas create a calm, structured appearance. This nebula is the remains of a star similar to the Sun, offering a peaceful preview of what our star will one day become billions of years from now. Fact 98 turns to supernova remnants, nebulae formed from the explosive deaths of massive stars. While supernovae themselves are powerful events, their remnants expand slowly afterward, creating intricate webs of gas and dust. The Crab Nebula, formed from a supernova recorded in 1054, glows with ethereal tendrils shaped by energetic winds. Despite their violent origins, these remnants evolve into delicate patterns, as if the universe repaints itself with gentle strokes. Fact 99 highlights dark nebulae. These clouds of dense dust block the light behind them, creating shapes like silhouettes against the bright backdrop of the Milky Way. The Horsehead Nebula is one of the most famous examples, a dark, horse-shaped figure emerging from a glowing red cloud. Dark nebulae evoke a sense of stillness, as if the universe has carved out shadows to rest in. Fact 100 takes us to Bok globules, small, isolated, dark clouds within larger nebulae. They may look unassuming, but inside, stars are quietly forming. Bok globules are like tiny pockets of cosmic privacy, where star formation unfolds away from the brighter regions around them. Their calm, compact appearance suggests that even small corners of the universe hold deep significance. Fact 101 explores the Rosette Nebula, a vast cloud shaped like a cosmic flower. Its petals are formed by gas and dust illuminated by a cluster of young stars at its center. The nebula's shape resembles a delicate bloom suspended in space, its symmetry, enhanced by the winds of the stars inside, makes it one of the most aesthetically soothing sights in the cosmos. Fact 102 moves to the Carina Nebula, a massive cloud in the southern hemisphere sky. Within it lies Eta Carini, one of the most luminous and volatile stars known. Yet despite this star's turbulent nature, the nebula around it glows with calm clouds of red, gold, and blue. Towering pillars of dust rise like mountains in slow motion, shaped by stellar winds and radiation. Fact 103 introduces the concept of nebular chemistry. Nebula contain elements such as hydrogen, helium, carbon, oxygen, the building blocks of life. Within these clouds, molecules form through slow interactions. When we look at nebulae, we are seeing the birthplace of the same elements that eventually become planets, oceans, and living beings. Nebulae are both peaceful and essential. Fact 104 reminds us that nebulae often grow over time as stellar winds carve out cavities and shape their edges. These winds push gas outward like a soft breeze drifting across a foggy field. The process is gradual and patient, forming elaborate patterns that can last millions of years. Fact 105 discusses how nebulae fade. As their gas becomes part of new stars or disperses into space, nebulae lose their glow. Their light dims until they become invisible. Even this fading is gentle, a quiet transition from visibility to memory. Fact 106 highlights that some nebulae are so faint they can only be photographed with long exposures. Human eyes cannot see their colors directly, but sensitive cameras reveal their hidden beauty. This reminds us that the universe holds wonders that only appear when we slow down and patiently collect their light. Fact 107 introduces the Veil Nebula, a supernova remnant spanning about 110 light-years. Its thin, colorful filaments resemble delicate strands of fabric floating in space. The nebula's appearance is light, airy, almost weightless. Its threads drift across the sky like cosmic lace. Fact 108 brings attention to the California Nebula, so named because its shape resembles the outline of California. It glows in red light from ionized hydrogen, stretching across the sky like a serene, elongated cloud. Although it covers an area larger than the full moon, it is too faint to see without photography. Fact 109 touches on the fact that nebulae often lie thousands of light-years away, yet their light reaches us with clarity. Even after traveling such distances, their glow remains calm, unhurried, and steady, arriving as if carried by a gentle cosmic breeze. Fact 110 closes this section with a quiet reflection. Nebulae are the universe breathing. They expand and contract, birth stars and release clouds, form shapes, and let them fade. They are the softest structures in the cosmos, yet they hold everything necessary to create new worlds. In their calm presence, you can feel the peaceful, unhurried rhythm of space itself. Galaxies are the great cities of the cosmos, drifting silently through an endless night. Each one contains billions or even trillions of stars. Yet, from a distance, they look serene, like soft spirals or glowing ellipses suspended in space. Their shapes, motions, and histories unfold slowly, on timescales so long that they naturally bring calm to the mind. In this part, we wander gently through these stellar cities, exploring their quiet wonders with unhurried curiosity. Fact 111 begins with the Milky Way itself. Our galaxy is a barred spiral containing somewhere between 100 and 400 billion stars. From Earth, we see only a faint band of light stretching across the sky. But if we could step outside the galaxy, we would see a radiant wheel, its arms curling gracefully outward. At the center lies a dense bulge of ancient stars, arranged like a soft, glowing heart. The entire structure rotates slowly, completing one full turn, roughly every 230 million years. Fact 112 introduces the Andromeda Galaxy, our nearest large galactic neighbor. Although it is 2.5 million light-years away, Andromeda is visible to the unaided eye from dark locations as a faint, misty patch. It is larger than the Milky Way and approaches us at about 110 kilometers per second. But even at that speed, the collision between our galaxies is not expected for another 4 billion years, demonstrating the slow, steady choreography of cosmic motion. Fact 113 explores dwarf galaxies. These are small clusters of stars, often orbiting larger galaxies like satellites. Some dwarf galaxies contain only a few million stars, making them incredibly faint. The Milky Way has dozens of dwarf companions, including the Sagittarius dwarf spheroidal galaxy and the Sculptor dwarf galaxy. These small galaxies move quietly through space, their stars loosely bound, drifting like tiny lanterns near the edge of our cosmic city. Fact 114 touches on the large and small Magellanic Clouds, two irregular dwarf galaxies visible from the southern hemisphere. They appear as hazy clouds in the night sky, each one containing millions of stars and active star-forming regions. They orbit the Milky Way, but also interact with each other, pulling and shaping their gas. Their presence has guided navigators for centuries, glowing softly over the southern oceans. Fact 115 brings us to spiral galaxies. These familiar shapes have sweeping arms that radiate from a central bulge, forming patterns that look almost hand-drawn. The arms contain young stars and bright nebulae, while the center often holds ancient stars packed tightly together. Spiral galaxies are among the most photogenic structures in astronomy, their symmetry soothing and balanced. They evoke thoughts of seashells, whirlpools, and other natural spirals found throughout the universe. Fact 116 describes barred spirals like our own Milky Way. In these galaxies, the central bulge is crossed by a long bar of stars from which the spiral arms emerge. The bar region gently directs gas inward, fueling new star formation. These bars act like cosmic currents, slowly channeling material toward the center. Over billions of years, bars can evolve, dissolve, or reform, illustrating the quiet, long-term nature of galactic evolution. Fact 117 shifts two elliptical galaxies. These galaxies have smooth, rounded shapes with little or no spiral structure. Their stars tend to be older, and they contain less gas than spirals. Ellipticals range from small, dim forms to enormous giants that dominate galaxy clusters. Their uniform glow gives them a gentle, peaceful appearance, as though they are fully settled into cosmic adulthood. Fact 118 explores lenticular galaxies. These are hybrids of spiral and elliptical galaxies, flat and disc-shaped, but without distinct spiral arms. They appear like smooth, glowing disks floating in space. Lenticular galaxies often have very little star formation, making them calm and stable environments filled with aging stars. Their simplicity gives them an elegant, minimalist beauty. Fact 119 highlights irregular galaxies. Unlike spirals and ellipticals, irregular galaxies lack a clear shape. Their stars, gas, and dust appear scattered and asymmetrical. These galaxies often form when gravitational interactions distort their structure. Despite their chaotic appearance, they host rich regions of star formation and serve as reminders that cosmic beauty does not always follow patterns. Fact 120 introduces galaxy clusters, the largest gravitationally bound structures in the universe. A cluster can contain hundreds or thousands of galaxies, all orbiting a common center of mass. These clusters drift together like constellations of galaxies, surrounded by dark matter and faint, hot gas. Their scale is almost unimaginable, yet they move slowly and steadily, like vast islands floating through a cosmic sea. Fact 121 describes the local group, the small cluster that includes the Milky Way, Andromeda, and dozens of dwarf galaxies. The local group spans about 10 million light-years. Its members orbit gently, forming a quiet neighborhood within the larger universe. This group itself lies at the edge of the Virgo supercluster, a much larger web of galaxies interconnected on an even grander scale. Fact 122 discusses supercluster Siemens structures containing many galaxy clusters linked together by gravity. One of the largest known is the Laniakea supercluster, which includes the Milky Way and stretches across 500 million light-years. The name Laniakea means immense heaven in Hawaiian, reflecting both its size and its beauty. Within these superclusters, galaxies flow along gravitational pathways, like rivers moving through a landscape. Fact 123 focuses on colliding galaxies. Although the stars within them rarely collide, due to the vast distances between them, the galaxies interact through their gravity, stretching each other into elongated shapes. The antennae galaxies are a classic example, forms pulled apart into long, graceful arcs. These collisions trigger bursts of star formation, lighting up the galaxies like cosmic fireworks. Yet the motion itself is extremely slow and quiet, unfolding over hundreds of millions of years. Fact 124 explores starburst galaxies, where rapid star formation occurs. These galaxies shine brightly in infrared light because their dust absorbs starlight and re-emits it as heat. Starburst activity doesn't last long in cosmic terms, but during these periods, galaxies glow intensely. Even so, the process remains gentle at human scales, like a quiet but energetic bloom of light. Fact 125 explains that most large galaxies contain supermassive black holes at their centers. These black holes can weigh millions or billions of times the mass of the Sun. When gas and stars come too close, the material spirals inward, becoming extremely hot and bright before crossing the event horizon. This process creates active galactic nuclei, some of the brightest objects in the universe. Yet, from far away, the glow appears as a steady, constant light. Fact 126 highlights quasars, distant galaxies with extremely luminous centers powered by accreting black holes. Quasars are so bright they can outshine their entire galaxy, visible across billions of light years. Their light carries stories from the early universe, drifting gently to Earth over unimaginable distances. Fact 127 reminds us that galaxies group together in filamentary patterns. These filaments weave through the cosmos like threads in a tapestry. In between lie vast voids, enormous areas with very few galaxies. The overall structure resembles a cosmic web. Though vast and complex, the entire pattern feels serene, like a sprawling painting created on a universal canvas. Fact 128 explores the idea that galaxies evolve over billions of years. Spirals merge into ellipticals. Dwarfs get torn apart and absorbed. Gas dwindles and star formation fades. These transformations are slow and graceful, like geological changes on Earth's only, stretched across cosmic time. Fact 129 notes that some galaxies are incredibly small, known as ultra-faint dwarf galaxies. They contain only a few thousand stars and almost no gas. Their faintness makes them extremely hard to detect. They drift quietly, almost invisible, like small whispers in the cosmic night. Fact 130 highlights ultra-diffuse galaxies. These galaxies can be as large as the Milky Way, but contain far fewer stars, making them extremely faint. They appear ghostly and transparent, like faint smudges floating through space. Their low density gives them a soft, ethereal quality. Fact 131 turns to ring galaxies, which have circular shapes formed when one galaxy passes through another. The Cartwheel Galaxy is an enchanting exemplar, glowing ring with spokes radiating from the center. The ring marks the ripple of star formation triggered by the collision, expanding outward like a wave on still water. Fact 132 brings attention to tidal tails, long streams of stars pulled from galaxies by gravitational interactions. These tails stretch across space like ribbons, sometimes forming elegant curves thousands of light years long. They are signs of past encounters, drifting slowly away from their galaxies. Fact 133 reminds us that galaxies recycle their material. Stars form, die, and return gas to the galaxy. That gas forms new stars. The cycle continues for billions of years, creating a rhythm of birth and renewal that echoes the slow heartbeat of the cosmos. Fact 134 quietly emphasizes that galaxies drift through space, influenced by dark matter. This invisible mass shapes their motions and structures, forming unseen frameworks that hold the cosmic web together. Though invisible, dark matter gives galaxies their stability and their graceful rotation. Fact 135 concludes with a thought that galaxies are serene, steady companions in the universe. They move, evolve, and glow across billions of years, embodying the patience of cosmic time. When you picture a galaxy drifting through the dark, spiraling gently, it invites the mind to slow down, breathe, and rest. Nebulae are among the quietest and most soothing objects in the universe, vast clouds of gas and dust that float gently in space. They glow softly or drift invisibly, shaping the life cycle of stars and adding color to the darkness. In this part, we wander through these peaceful regions, star nurseries, remnants, and ethereal clouds, each one offering a calm reminder of how slowly and gracefully the cosmos evolves. Fact 136 begins with a simple idea of what a nebula truly is. A nebula is a cloud of gas and dust, often composed mainly of hydrogen and helium, the most common elements in the universe. Although many nebulae appear bright and colorful in images, most are extremely faint to the human eye. Their beauty comes from slow, steady processes: gas illuminated by starlight, dust scattering photons, and gravity pulling material together over millions of years. Fact 137 brings us to the Orion Nebula, one of the most famous and closest star-forming regions to Earth. Located about 1,350 light-years away, it is visible to the naked eye as a faint smudge in the sword of Orion. Telescopes reveal swirling clouds lit by young, hot stars. The nebula glows because those stars energize the surrounding gas, making it shine. The Orion Nebula is still busy forming stars. Though busy in cosmic terms means working slowly and quietly over millions of years. Fact 138 explores emission nebulae. These glowing clouds produce light because they are energized by ultraviolet radiation from nearby stars. Their reddish or pinkish glow comes from hydrogen gas, specifically from electrons recombining with protons after being energized. It is a soft, warm color, reminiscent of sunrise seen from another world. Fact 139 shifts to reflection nebulae. Reflection nebulae do not produce their own light. Instead, they scatter blue light from nearby stars, turning them into misty blue clouds drifting through space. The Pleiades cluster contains well-known reflection nebulae, their gentle blue haze visible even in small telescopes. Fact 140 moves to dark nebulae, some of the most peaceful-looking objects in the sky. These clouds are dense enough to block light from stars behind them. They appear as dark shapes against the brighter regions of space, like quiet shadows drifting through the cosmos. The Horsehead Nebula is a striking example of silhouette shaped like a horse's head, outlined against a glowing background. Fact 141 takes us to planetary nebulae, which are not related to planets at all. Instead, they form when a dying star, similar to our Sun, gently sheds its outer layers. As the material drifts outward, it becomes illuminated by the remaining core of the star, creating a glowing shell. Planetary nebulae come in many shapes: circles, ovals, rings, and intricate patterns, each formed by the gentle physics of stellar winds and gravity. Fact 142 highlights the Helix Nebula. Sometimes called the Eye of God, it is a large planetary nebula located about 650 light-years away. Its structure looks like a giant blue eye surrounded by filaments. This peaceful, symmetrical formation is the result of a star slowly releasing its outer layers at the end of its life. When viewed in infrared, the Helix Nebula appears even more delicate, with wisps of gas drifting like cosmic threads. Fact 143 turns to the Crab Nebula, a supernova remnant created by a star that exploded in 1054 CE. Although the event was violent, the nebula left behind is quiet and stable today. It expands slowly, about 1,500 kilometers per second, forming a tangled web of gas. In its center lies a neutron star, tiny yet incredibly dense remnants per second. Despite its activity, the nebula's appearance from Earth feels soft, like colored smoke gently drifting outward. Fact 144 explores supernova remnants in general. These structures form after massive stars explode, sending their outer layers into space. Over thousands of years, these remnants cool, slow down, and mix with interstellar gas. Although their origins are explosive, the remnants themselves become some of the most serene objects in astronomy. They expand quietly, their filaments twisting slowly like drifting silk. Fact 145 shifts 2 protostars, soon stars forming inside dense nebulae. Protostars are hidden within dark clouds, slowly gathering material until nuclear fusion begins. This process takes hundreds of thousands of years. The slowness of star formation is one of the most comforting facts in astronomy. Nothing rushes, nothing hurries. Everything unfolds at a peaceful, cosmic pace. Fact 146 focuses on Bok globules, tiny dark clouds that contain the seeds of future star systems. Bok globules are small, dense patches of dust and gas that appear as round or irregular dark shapes. Inside them, gravity slowly compresses material until new stars ignite. They are like cosmic cocoons, quiet, simple, and essential to the continuation of stellar generations. Fact 147 brings us to the Carina Nebula, a vast star-forming region located about 8,500 light-years away. It contains some of the most massive and luminous stars known. Despite their size, the nebula as a whole emits a gentle appearance with glowing gas-forming waves, pillars, and flowing patterns. Even the dramatic pillars of Carina look like soft sculptures of light and shadow. Fact 148 examines the Ego Nebula, home to the famous pillars of creation. These towering columns of gas and dust stretch for several light-years. They are slowly being eroded by stellar winds, revealing hidden stars within. While the name Pillars of Creation evokes drama, the structures themselves change gradually, like mountains shaped by wind over geologic time. Fact 149 turns to the Rosette Nebula, a circular cloud with a cavity carved out by young stars in its center. The nebula's structure resembles a soft, blooming flower, its petals formed by glowing gas. This serene formation highlights how astrophysical forces can create shapes that feel poetic and organic, even though they occur on scales larger than entire solar systems. Fact 150 explores the Veil Nebula, another supernova remnant that stretches across 110 light-years. Its delicate filaments of gas twist and curl like wisps of smoke. The colors seen in images come from different elements: hydrogen, sulfur each, one glowing softly in the vacuum of space. Fact 151 discusses star formation triggers. Shock waves from old supernova, gravitational interactions between clouds, or gentle compressions as nebulae drift through the galactic environment can all lead to new stars forming. Nothing happens suddenly. Changes begin slowly, almost imperceptibly, and unfold across cosmic ages. Fact 152 introduces Urbic Haro, objects, small, bright patches of nebulosity formed when protostellar jets collide with surrounding gas. They shimmer with gentle arcs of light, revealing where young stars are actively shaping their environment. These objects change noticeably over decades, offering rare glimpses into evolving cosmic structures humans can observe in a single lifetime. Fact 153 considers diffuse nebulae, large regions of gas that stretch over vast distances. Their edges blend softly into space, giving them a dreamlike appearance. These nebulae form the background glow in many images of the Milky Way, adding depth and serenity to the galactic landscape. Fact 154 turns to molecular clouds, densest parts of nebulae where new stars and planets are born. Temperatures in these clouds can drop to 260 degrees Celsius. At such low temperatures, atoms move slowly, and even chemical reactions unfold at a gentle pace. Molecular clouds are like cosmic cradles, hosting the earliest stages of solar systems. Fact 155 highlights the Trifid Nebula, a fascinating object combining emission, reflection, and dark nebulae in one. Red, blue, and dark regions come together like soft pastels spread across the sky. The dark lanes divide the nebula into 3 sections, giving it a peaceful yet structured appearance. Fact 156 brings us to the Lagoon Nebula, a bright, sprawling cloud in Sagittarius. It contains rich, star-forming regions and subtle dust lanes. Observations reveal bubbles and streams created by young stars, but their motion is slow and gentle, something that unfolds over thousands of years. Fact 157 explores the concept of stellar nurseries. These are nebulae where hundreds or thousands of stars form together. Called open clusters once the stars emerge, these groups drift apart over time as they orbit the galaxy. The transformation from nebula to cluster is a quiet story of birth and dispersal written across millions of years. Fact 158 describes the life cycle of nebulae themselves. Clouds form, collapse into stars, disperse, and sometimes reform later. Nothing in space is wasted. This cycle is one of the most common ideas in astronomy. The universe gently reuses everything. Fact 159 turns two unusual nebula shapes. Some nebulae appear like butterflies, shells, or abstract patterns. The butterfly nebula, for example, resembles wings of glowing gas stretching outward. The cat's eye nebula contains swirling loops and knots, almost like a cosmic mandala. These forms arise naturally from physics, yet feel almost artistic. Fact 160 concludes our gentle visit to the world of nebulae with a simple reminder. Nebulae show the universe at its most patient. They change, form, dissolve, and reform over unimaginable timescales. They are peaceful reminders that creation often begins in quiet, hidden places. When you imagine a nebula, soft, glowing cloud drifting silently through space, becomes a picture of cosmic stillness, perfect for deep relaxation and rest. In this calm stretch of our journey, imagine yourself drifting deeper into the quiet spaces between stars, where the universe feels both endlessly vast and delicately organized. Part of what makes space so comforting to learn about at night is this gentle truth. The cosmos follows clear, predictable rules, yet at the same time, it's shaped by processes that appear chaotic, random, and full of surprises. Tonight, we explore that balance, the quiet tension between order and disorder, the patterns that hold galaxies together, and the unpredictable forces that sculpt them over billions of years. This balance is one of the softest, most soothing ideas in astronomy, because it reminds us that harmony can exist even in the middle of cosmic turbulence. As you relax, imagine a spiral galaxy slowly turning like a vast celestial pinwheel. One of the first facts to settle into is that spiral shapes aren't accidental. They arise from density waves, subtle patterns rippling through galactic disks. Stars move in and out of these waves the same way cars travel through slow-moving traffic on a highway. The shape emerges naturally, no guiding hand required. It's a peaceful example of cosmic order, a structure created simply by the rhythm of movement and gravity. Yet within these graceful arms, chaos still exists. Supernova explosions, clouds collapsing into stars, clusters separating over millions of years. Order and chaos layered delicately together. This mixture becomes even clearer when we consider how stars form. Star formation often begins in what look like turbulent, disorganized clouds of gas and dust. These clouds span dozens, sometimes hundreds, of light years, their surfaces shaped by radiation, magnetic fields, and shock waves. They have no clear borders, no clean patterns. Yet from this apparent disorder comes one of the most orderly processes in nature: gravity pulling matter inward, forming perfect spheres of light. A star ignites, and another fixed point of brightness appears in the sky. Something wild and unstructured gives birth to something stable. It's a pattern repeated across the cosmos, again and again. Even black holes, often imagined as symbols of chaos, are among the most predictable objects in existence. They have no internal structure we can see, no complicated surfaces or landscapes. Their behavior is determined by just three things: mass, charge, and spin. That simplicity is striking when compared with the violent processes that produce them. Sometimes it comes from the collapse of a massive star. Sometimes from the merger of two smaller black holes spiraling toward each other. These events shake spacetime itself, creating gravitational waves that ripple across the universe. The birth may be chaotic, but the result is something profoundly simple, almost elegant. Nature transitions seamlessly between the unpredictable and the orderly. Now, imagine standing quietly beneath a night sky, looking up at a familiar constellation. We see patterns, shapes, stories. Yet those patterns are illusions of perspective. The stars we group together can be tens, hundreds, or thousands of light years apart. They're not connected, except in our imaginations. Humans created constellations as a way to bring order to something overwhelming. The universe didn't design them, people did. And yet, the act of creating patterns is itself a response to the quiet structure of the heavens. Stars stay fixed relative to one another over human lifetimes because of the immense distances between them. Their slow drift is so gentle we don't notice it without long-term measurements. Chaos in their motions exists, but so slowly, so delicately, that to us, the sky appears permanent and perfectly arranged. Beyond the constellations, the universe's large-scale structure reveals something even more surprising. Maps of galaxies show a cosmic web, filaments stretching for hundreds of millions of light years, with clusters gathering at their intersections and gigantic, empty voids between them. From a distance, it looks like neurons in a brain or threads in a spider's web. This shape arises naturally from tiny fluctuations in the early universe, random, quantum-level variations that gravity amplified over billions of years. Random seeds blossoming into vast, interconnected patterns. The balance between chance and structure written across unimaginable distances. Take our own solar system. The planets travel in stable orbits, following precise paths predicted by classical physics. Their motion is rhythmic, almost musical. At the same time, the early solar system was anything but peaceful. It was filled with collisions, fragments, and leftover building blocks of planets bumping into one another. The moon was created from one of these giant impacts. So were many of the small bodies that now inhabit the asteroid belt and Kuiper belt. Today, we see stability, but that stability grew from turbulence and instability. The calm was earned. One of the gentlest examples of this balance can be found in the motion of comets. A comet wandering into the inner solar system has an unpredictable path shaped by past gravitational encounters, subtle tugs from planets, and small jets of gas escaping its surface. Yet, despite this unpredictability, many comets follow long, repeating cycles. They return every few decades or centuries, tracing ancient routes through the sky. Their cores are frozen time capsules, products of early chaos. Their orbits are traces of cosmic order, and their glowing tails brief, beautiful, shaped by the sun's light and solar wind, creating luminous arcs across the night. Galaxies themselves grow through a combination of gentle processes and violent transformations. Some of their stars form slowly and peacefully from cooling gas. Others form in bursts, triggered by collisions with neighboring galaxies. These galactic encounters are common, especially in dense regions of the universe. What seems like chaos, a galaxy passing through another, stars flung in new directions, gas clouds compressed ends up, creating new order. Over millions of years, these interactions cause galaxies to settle into new shapes, new orientations, new harmonies. This interplay becomes even more poetic when we consider the life cycle of elements. Hydrogen and helium emerged from the universe's earliest moments. Everything else, carbon, oxygen, nitrogen, iron, came from stars. Stars build elements in their cores, fuse them slowly over billions of years, and then release them into space through gentle winds or explosive supernova. These materials mix, gather, form new stars, planets, and eventually, life. It's a cycle shaped by both destruction and creation. The chaotic deaths of stars lay the groundwork for the calm stability of new solar systems. The atoms in your body once existed in the heart of stars that lived and died long before Earth formed. From cosmic disorder came the peace of life. Even the expansion of the universe reflects this theme. Galaxies drift apart as space itself stretches. The rate of expansion accelerates, driven by the mysterious presence of dark energy. We don't fully understand dark energy, and yet its effects are consistent, measurable, and predictable across cosmic time. Something unknown, yet orderly. Something invisible, yet responsible for shaping the universe's future. The interplay continues, mystery and structure side by side. We see this again in the ways planets evolve. Some worlds, like Mars, show evidence of ancient rivers and lakes. Today, those features are dry, carved by winds and time. What was once dynamic has become quiet. Other planets, like Venus, may have once been calmer than they are now. Venus's runaway greenhouse effect turned its surface into a hot, dense, uninhabitable environment. Slowly shifting conditions, influenced by geology and atmosphere, turned order into chaos. And yet, the movements of those same atmospheres follow precise physical laws. Patterns emerge in clouds, temperatures, and winds. Even turmoil has rhythm. As you breathe slowly and settle deeper into relaxation, consider how this cosmic duality mirrors the patterns of human life. Order and unpredictability coexist. Stability forms from change. Beauty emerges from both structure and randomness. The universe doesn't choose one or the other. It holds both effortlessly. In the next part of our journey, we'll explore how stars communicate their properties through the quiet language of light, how astronomers decode that light too. Learn about temperature, distance, age, and composition, much like reading a story written by the universe itself. There is a special kind of calm that arrives when we imagine the vast drifting clouds that fill the spaces between the stars. These enormous, dim regions, called interstellar clouds, or sometimes nebulae, move slowly through the galaxy like quiet rivers of gas and dust. Even though they seem empty at first glance, they hold the raw materials for future suns, future planets, and perhaps future forms of life. So tonight, let us float gently through these ancient structures, letting their cosmic stillness guide the mind deeper into rest. One of the first things to know is that interstellar clouds are not uniform places. Some are dense, cold, and heavy with molecular gas, while others are warm and diffuse, barely more than faint hints of dust. The universe is filled with variety, and this diversity plays an important role in shaping future solar systems. In the coldest parts of these clouds, temperatures fall to just a few degrees above absolute zero. At that level of chill, molecules move so slowly that they can cling to tiny dust grains, collecting layer after layer until these specks become seeds for much larger structures. There is patient beauty in the way nature builds from the smallest ingredients you can imagine, drifting through the darkness, a small particle no larger than a grain of smoke. Over thousands and thousands of years, it collects frozen molecules, bits of water, carbon monoxide, perhaps the faint beginnings of complex organic compounds. These compounds, in turn, may become significant once a star is born nearby, because the early light of a newborn star has a way of heating, melting, and transforming these frozen mixtures. Out of that process, chemistry grows more intricate. Some scientists believe that these gentle beginnings may even contribute to the chemistry of life when such grains eventually fall onto young planets. Interstellar clouds offer two qualities that might seem contradictory at first. They are incredibly delicate, yet immensely powerful in their long-term influence. A single shockwave from a supernova passing through one of these clouds can compress the gas enough to start a chain reaction of star formation. Something that appears soft and quiet, nothing more than a faint blur, through a telescope can give rise to clusters of radiant stars, each one destined to shine for millions or billions of years. This interplay between gentleness and creative force is one of the most soothing aspects of cosmic evolution. Consider also how these clouds contribute to the overall structure of galaxies. Spiral galaxies, like the Milky Way, have long arms filled with patches of star-forming regions. These pockets mark the locations of molecular clouds. They glow faintly in infrared light, which is why astronomers use specialized telescopes to map them. While visible light might pass through, infrared light reveals the warmth of dust and gas, showing where new celestial life is stirring. There is something peaceful about this, no matter how enormous the galaxy is. And no matter how much time passes, star formation is a slow, steady rhythm that never fully stops. One of the most famous of these clouds is the Orion Molecular Cloud Complex. It sits within the constellation Orion, a familiar pattern of stars seen from many parts of the world. This massive region contains the bright Orion Nebula, the Horsehead Nebula, and several other well-known structures. What makes Orion so special is how clearly it demonstrates the stages of star formation. Some parts contain glowing gas lit by young stars, while other regions contain dark, cold filaments where future stars are only beginning to stir. The contrast between light and shadow, between creation and anticipation, gives Orion an almost poetic balance. When we speak of interstellar clouds, we are also speaking of incredible scales. Some of them stretch for dozens, even hundreds of light years. If you were to travel through one in a spacecraft, you would never see a wall or boundary. Instead, the surroundings would slowly shift over vast distances, from thin wisps to slightly denser pockets. The stars would appear dimmer because dust absorbs and scatters their light. Everything would seem softer, quieter, and muted. It is easy to imagine drifting among these clouds, guided only by the faint glow of distant starlight, as if floating through a cosmic fog. A surprising fact is that interstellar clouds contain many elements essential to planetary formation. Hydrogen makes up most of their mass, but there are also heavier elements like oxygen, carbon, nitrogen, silicon, and iron. These heavier atoms come from older stars that exploded billions of years ago. In this way, every interstellar cloud carries the heritage of previous generations of stars. When new stars form, they incorporate these elements. Their orbiting planets inherit them as well. In time, a rocky world might arise, complete with landscapes, oceans, or even life. It is remarkable to think that the air we breathe, the minerals beneath our feet, and the water that fills our seas all originated in long-lost interstellar clouds. The process that leads from cloud to star is gradual and soothing to imagine. Over time, gravity gathers material into a dense clump. As more material falls inward, the pressure and heat at the center begin to rise. Eventually, temperatures become high enough for nuclear fusion to start. In the same gentle moment, a new star is born, and the surrounding cloud begins to glow with a soft radiance. What had been a cold, dark region becomes warm and luminous. Astronomers call these glowing regions H2 regions, named after ionized hydrogen. Although the name may sound technical, the effect is like watching a candle spark to life in a quiet room. Beyond the molecular clouds and glowing nebulae lie even darker structures called Bok globules. These small, dense pockets look like drops of ink against brighter backgrounds. They are among the most mysterious parts of star-forming regions. Inside them, protostars may be forming, hidden from view by thick dust. These globules are reminders that some of the universe's most delicate processes take place far from sight, in silence, without hurry. In that way, they echo the quiet rhythms of sleep. What makes these clouds especially soothing to contemplate is the sense of continuity they provide. Even as stars age and fade, their remnants enrich the galaxy with new materials. Those materials drift into nearby clouds, combining with the existing gas. Over millions of years, the cycle begins again. Clouds collapse, stars ignite, planets form, and eventually, life may awaken. This slow, repetitive pattern offers a comforting kind of predictability. The universe is immense, but its long cycles remain dependable. Modern telescopes have given us exquisite images of these clouds filled with color and detail. In reality, our eyes would not see them so vividly. The colors in photographs often represent wavelengths beyond human vision, such as infrared or ultraviolet light. Yet, these enhancements help reveal the true complexity of the clouds. They show twisted filaments, graceful arcs, and pillars shaped by stellar winds. They show areas where gas is evaporating under intense radiation. They show the silent conversations between matter and energy that shape entire regions of space. Tonight, as we drift through the soft, muted depths of these interstellar clouds, it becomes easy to let the mind gently loosen its grip on the day. Thoughts slow, as if moving through the cold, dense stillness of a molecular cloud. Emotions soften like starlight dimmed through dust. And through it all, there remains a sense of quiet possibility, because in these clouds, every star that will ever shine is already waiting. There is something deeply soothing about the idea of motion that never rushes, never falters, and never needs correction, motion that follows gentle loops through space for millions or even billions of years. That is what orbits are. The quiet choreography of celestial bodies moving in harmony. Tonight, we drift into that slow, predictable rhythm, tracing soft paths around stars, moons, and planets, as if we, ourselves, are weightless observers floating in the dark. The first thing to remember is that orbits are not perfect circles, though they can look that way from far away. Most are elongated ellipses, slightly stretched, gently shaped by the laws of gravity. These ellipses were first described by the astronomer Johannes Kepler in the 17th century, but their beauty has existed since the universe began. You can imagine each planet as a traveler moving around the sun in a rhythm that has repeated for eons, with smaller variations that unfold across long time scales. Nothing in celestial motion is abrupt. Everything is smooth, continuous, and steady. What makes orbits so calming to think about is their mixture of balance and freedom. A planet is always falling toward the star at its center, pulled inward by gravity. But it is also always moving forward, fast enough that it never reaches the star's surface. Instead, it falls around the star, caught in an endless, graceful loop. This delicate balance offers a kind of cosmic reassurance. Motion can be stable, predictable, and peaceful, even in the vastness of space. The Earth's orbit is one of the most stable we know. Each year, the planet completes its trip around the sun, traveling nearly 1 billion kilometers along its elliptical path. Even though this path is huge, the temperature and light we receive remain remarkably steady. That stability is essential for life, for climate, for oceans, and for every ecosystem. Without Earth's calm, even orbit, the world would be a very different place. Seasons would wobble unpredictably, perhaps too drastically for life to flourish. Instead, we live in a world with rhythms: summer, autumn, winter, spring, each one guided by the soft tilt of Earth's axis and the smooth curve of its orbit. If you could watch the solar system from above, from a vast, peaceful distance, you would see each planet tracing its own oval path. Mercury moves swiftly, racing around the sun in just 88 days. Venus glides with perfect consistency, its slow rotation creating a strange sense of stillness. Earth moves at a comfortable pace, not too fast, not too slow. Mars, with its rusty hue, swings around in a wider orbit. Farther out, the gas giants, Jupiter, Saturn, Uranus, Neptune circle slowly like ponderous giants crossing a darkened ballroom. These massive planets exert their own influence. Jupiter, for instance, is so large that it slightly shifts the sun as they orbit around a shared center of mass. Nothing in space moves alone. Everything feels everything else, even if that pull is faint. The gravitational threads connecting planets, moons, and asteroids form a web of invisible ties that keeps the solar system in balance. And though these ties are silent, they are strong enough to guide worlds, moons, to follow their own orbits. Earth's moon keeps a slow, steady pace, completing one full orbit every 27 days. Its presence stabilizes Earth's tilt, helping maintain the gentle regularity of the seasons. On Jupiter, dozens of moons circle like a miniature version of the solar system. Some of them, like Io, Europa, and Ganymede, experience tidal interactions so strong that their surfaces flex and shift over time. Yet, even this internal motion follows a predictable pattern. Orbits enforce order, even in worlds of fire and ice. Saturn's rings create one of the most mesmerizing orbital systems. Each ring is made of countless bits of ice and rock, all orbiting the planet at different speeds. From a distance, the rings look solid, like smooth, flat disks. But up close, they are made of swirling particles that never collide for long, always finding equilibrium again. Millions of tiny orbits interlock to create a feature of ethereal elegance. If you listen in your imagination, asteroids obey the same laws of motion. They drift through the solar system in wide elliptical paths, some clustered in the asteroid belt, some wandering independently. Comets take even more dramatic orbits, stretching from the distant edges of the solar system to the warm interior near the sun. A comet's orbit can last many lifetimes, looping through darkness for centuries before returning to the inner solar system in a brief display of shimmering tails and glowing gas. Their journeys remind us that even the most distant travelers eventually return home. The laws that guide all these motions are simple. Gravity pulls objects toward one another, and the momentum of their movement carries them forward. This balance creates continuous, flowing curved paths that cross vast distances with gentle precision. These laws apply not only to planets, but to stars orbiting the centers of galaxies, and even to galaxies orbiting one another in clusters. The entire universe is filled with these soft, circular motions. When we think about orbits on larger scales, the calmness becomes even stronger. Our solar system is not still. It orbits the center of the Milky Way, completing one full circuit every 230 million years. That means the last time our solar system was in its current position in the galaxy, dinosaurs roamed Earth, and long before them, early life was only beginning to emerge in the oceans. In all that time, the solar system has continued its slow, patient journey around the galactic core. The Milky Way itself is interacting with nearby galaxies, including the Andromeda galaxy. The two are moving toward each other in a dance that will take billions of years to complete. Eventually, they will merge, not in a catastrophic crash, but in a long, graceful blending of stars and gas. Even on cosmic scales, nothing rushes. Even collisions are quiet, stretched across unfathomable spans of time. Stars rarely collide. Instead, they drift past each other like lanterns floating on a calm sea. The serene predictability of orbits gives astronomers the ability to look into the distant future. They can calculate where planets will be thousands of years from now. They can track the motions of asteroids, predicting when some may come close to Earth. They can estimate the future shapes of galaxies. All of this is possible because the universe, for all its expansiveness, follows gentle rules. These rules create order out of enormity and peace out of distance. There is a special kind of comfort in imagining yourself drifting along one of these orbits. Perhaps you are following Earth's path, gliding steadily through space at 30 kilometers per second. There is no wind, no sound, no frictionally, the constant, smooth movement. Ahead of you, the curve continues forever. Behind you, the path is perfect and unbroken. All around you, the stars shift slowly, like dim lanterns in a vast, peaceful night. As you float there, in your imagination, let the steadiness of orbits settle into your mind. Everything moves with purpose. Everything follows its path. Everything is unhurried. The planets will continue circling the sun long after we are gone, and long after new civilizations come and go. The stars will drift through their cycles. The galaxies will swirl. And through all of it, the laws of motion will remain calm and dependable. Let that stability wrap gently around your thoughts, like a slow, predictable tide. Let it soften the edges of the day, and let it guide you deeper into the quiet where everything moves in harmony. There is a certain tenderness to light when you think about it, not the brightness that dazzles or overwhelms, but the gentle calm of something that has traveled across unimaginable distances just to arrive softly at your eyes. Tonight, we explore light itself, the quiet messenger of the universe. It carries the stories of stars, nebulae, and galaxies. It slips through space without sound, without weight, without ever growing tired. And in the stillness of night, especially when you are drifting toward sleep, it becomes something soothing, something almost alive. Light begins with energy, usually deep inside a star. Picture the core of the sun, where hydrogen atoms merge into helium through nuclear fusion. In that moment, energy is released, and part of that energy becomes light. But that light does not escape immediately. It bounces around inside the sun for thousands of years, traveling slowly through dense plasma, moving in random directions, scattering again and again, until it reaches the sun's surface. Only then does it finally stream outward, crossing the vacuum of space at a speed so steady it feels like a cosmic heartbeat. It takes light just over 8 minutes to reach Earth. That sunlight warms the planet, feeds ecosystems, powers the climate, and allows life to flourish. It touches oceans, forests, mountains, and cities in a way that is constant but never rushed. Even the photons coming through your window in the morning are ancient travelers, having begun their journey long before anyone alive today was born. Yet they arrive softly, falling on the earth like calm breath. One of the most peaceful ideas in astronomy is that the light we see from distant stars is old, sometimes unimaginably old. When you look at a star 1,000 light years away, you are seeing it not as it was 1,000 years ago. The night sky becomes a quiet archive, a library of celestial memories. Nothing in this vast archive speaks loudly. Everything whispers. Take the Andromeda galaxy. Its light takes more than 2 million years to reach us. Every faint glow from its spiral arms is a message from a time when early humans were still discovering simple tools. Light lets us look backward, as if space keeps a gentle time capsule waiting for anyone who wishes to observe. Galaxies farther away, send even older light. When astronomers peer into deep space, they see the early stages of the universe, its first stars, and its earliest structures. These ancient glimmers traveled for over 13 billion years to reach us. Imagine the patience of that journey, unbroken line of motion, uninterrupted, gliding through the cosmos for nearly the entire age of the universe. This is one reason telescopes are often described with words like graceful, delicate, or sensitive. A telescope does not capture loud events. It collects fragile strands of light, faint signals that might otherwise be lost in the darkness. Whether it is the James Webb Space Telescope observing distant galaxies, or a small backyard telescope looking at Jupiter, the principle is the same. Light arrives quietly, and we greet it with care. Starlight itself has a spectrum, a gentle range of colors that we can separate with a prism. These colors reveal secrets, the temperature of the star, its composition, its age, and even whether it is moving toward or away from us. Every color carries meaning. Redder light suggests cooler temperatures or greater distances. Blue light signals high energy and intense heat. When starlight stretches into deeper red tones, astronomers know the object is moving away. When it shifts slightly toward blue, they know it is approaching. Light becomes a universal language, readable from anywhere in the cosmos. Another calm phenomenon connected to light is the aurora, the soft glow of charged particles dancing near a planet's poles. On Earth, auroras shimmer in greens, pinks, and purples, like silent curtains of color. They happen because particles from the sun interact with the planet's magnetic field, guiding energy toward the poles where it meets the upper atmosphere. Even in this dance, there is no harshness. Everything falls into place with quiet elegance. If you were to watch the auroras of Jupiter or Saturn, you would see even more intense displays, larger but still silent in the vacuum of space. Light expresses itself in forms both gentle and grand. One of the most serene types of cosmic light is the cosmic microwave background, often called the afterglow of the Big Bang. This faint radiation fills the universe evenly, like a soft light that never turns off. It is the universe's earliest visible signature, dating back to a time when the cosmos was still young. And yet, despite its origin in a dramatic moment, the cosmic microwave background is remarkably tranquil. It is cool, uniform, and faint, perfectly fitting for a universe that has expanded and calmed over billions of years. Even black holes, which are known for trapping light, create a kind of cosmic art around them. As matter spirals inward, it heats up and emits light that forms a glowing disk. This accretion disk can be unimaginably bright, but if you imagine observing it from far away, it becomes something strangely peaceful, a flat, glowing ring encircling a region where light cannot escape. The boundary of a black hole, the event horizon, creates a soft curvature in the surrounding space-time, bending light like a lens. Nothing is abrupt. The bending is smooth, almost sculptural. Then, there are gravitational lenses themselves, vast galaxies or clusters whose mass bends the light from objects behind them. The result is arcs, rings, and smeared shapes that astronomers call Einstein rings. They are not chaotic distortions. They are symmetrical, balanced, and surprisingly beautiful. These lenses reveal distant galaxies we would never see otherwise. Light, which traveled in straight lines for billions of years, curves gently around massive objects and continues onward, arriving at Earth with its ancient story intact. On Earth, we see the quieter signatures of light in ways that feel familiar. Sunsets spread warm colors across the sky because shorter wavelengths scatter more easily. When the sun is low on the horizon, the long path through the atmosphere removes those shorter wavelengths, leaving reds and oranges to glow softly. Sunrises unfold with similar grace, bringing the world slowly out of darkness. These transitions are universal. If you stood on Mars, you would see a bluish sunset because of the different composition of its atmosphere. And if you visited Titan, Saturn's hazy moon, you would witness golden light filtered through thick, organic mist. Another gentle cosmic phenomenon is the zodiacal light, faint triangular glow visible after sunset or before sunrise. Created by sunlight reflecting off dust in the inner solar system. This dust is ancient, left over from the formation of planets drifting quietly for billions of years. When sunlight touches it, the result is a soft, ghostly glow, like a thin veil stretched across the sky. Starlight also changes depending on the atmosphere of the planet you observe from. On Earth, air turbulence makes stars twinkle. It is a charming effect, giving the night sky a sense of motion. From the moon, there is no atmosphere, so stars remain perfectly steady, sharp, and unwavering. The difference is subtle, but it reminds us how our planet shapes the way we experience the universe. Even bioluminescence, though not cosmic, echoes the quiet magic of light. Deep in Earth's oceans, tiny organisms create flickering glows that resemble miniature galaxies drifting in water. The patterns of their light, though small, feel cosmic in scale. In this way, light connects everything from plankton on Earth to the largest structures in the universe. As we drift deeper into this calm exploration, it becomes clear that light is not just illumination. It is a traveler, a storyteller, a guide. It connects stars to planets, galaxies to observers, and the past to the present. It reminds us that even across unimaginable distances, something can move softly and still carry meaning. So, as night surrounds you, let the idea of cosmic light settle gently in your thoughts. Think of photons gliding effortlessly through space, crossing valleys of darkness, passing by silent worlds, weaving through nebulae, and finally arriving here in this quiet moment. Light asks for nothing. It simply continues on, revealing beauty wherever it goes. There is a gentle truth about the universe that can be strangely comforting. Nothing is ever still. Everything drifts, glides, rotates, or expands. And yet, despite all this motion, the universe feels profoundly calm when you think about it at bedtime. Space is filled with quiet currents, graceful orbits, and slow changes that unfold over millions or billions of years. Tonight, you drift with that motion and let it lull your thoughts into an easy rhythm. It begins with rotation. Most cosmic bodies, from tiny asteroids to enormous stars, spin gently around their axes. This rotation isn't forced. It is a leftover property from the swirling motion of the clouds of dust and gas from which they formed. When matter collapses inward under gravity, it spins faster, much like a figure skater pulling in their arms. The same physics that governs a dancer's movement shapes the rotation of entire planets. Earth rotates once every 24 hours, creating the cycle of day and night. The quiet turning that ushers in sunrise and sunset without fail. Jupiter spins much faster, completing a rotation in just about 10 hours. This rapid rotation produces violent storms and powerful jet streams in its atmosphere. Yet, from a distance, the motion appears smooth, like softly swirling paint on a giant canvas. Saturn rotates almost as quickly, but its gaseous layers create different bands of color and movement. Uranus spins on its side, as though gently tipped over, giving it seasons that last more than 20 years each. And Neptune rotates with deep, cobalt blue swirls that shift like calm ocean currents. Stars rotate too. Some spin leisurely, while others rotate so quickly that their equators stretch outward, becoming slightly flattened. Our Sun rotates once every 27 days, but its equator rotates faster than its poles because it is not solid. The plasma flows differently in different regions, creating a slow, steady ballet of magnetic forces. Then there is orbital motion. Planets move around stars, moons orbit planets, and stars orbit the centers of their galaxies. These motions may seem fast when measured in kilometers per second. But because distances are so vast, the paths are wide arcs that take years or generations to complete. Earth moves around the Sun at about 30 kilometers per second. Yet, you never feel the movement. You are carried smoothly through space, held in the embrace of gravity, like drifting on a vast and invisible river. The Moon moves around Earth at about 1 kilometer per second, and its orbit creates the phases we see: full, crescent, new. These phases, repeating in a monthly cycle, form one of the oldest natural rhythms humans have observed. Before calendars, clocks, or technology, ancient cultures marked time by following the moon's slow and graceful motion. Beyond the solar system, stars orbit the center of the Milky Way. Our Sun takes roughly 225 to 250 million years to complete a single orbit, a journey sometimes called the cosmic year. Just imagine, since the Sun last completed a full orbit, the dinosaurs had not yet appeared, and Earth was covered in vast forests inhabited by creatures long extinct. Now, halfway through another galactic lap, the Sun continues its slow drift along the spiral arm called the Orion Arm, moving at a speed that seems enormous, yet feels serene in the emptiness of space. The Milky Way itself drifts. It is moving toward the Andromeda Galaxy at about 110 kilometers per second. In the far future, the two galaxies will merge, not in a violent crash, as one might imagine, but in a peaceful intermingling of stars. Because galaxies are mostly empty space, very few stars will collide. Instead, gravitational tides will gently mix them together, creating a new, larger galaxy. This event, though grand in scale, will be quiet, and it will take billions of years, unfolding slowly enough that no single moment will feel sudden. Even smaller cosmic bodies drift with an elegance shaped by gravity. Comets travel along long, elliptical paths, spending most of their time far from the sun. As they approach the inner solar system, sunlight warms their icy surfaces, creating tails that stream outward. These tails always point away from the sun, guided by solar wind rather than the comet's direction of travel. The result is a soft, luminous trail stretching behind them, marking their path like a brushstroke across the dark canvas of space. Asteroids move too. Some orbit between Mars and Jupiter in the asteroid belt, where thousands of rocky bodies glide through a region that is not crowded at all, contrary to movie depictions. They drift peacefully, separated by millions of kilometers, only occasionally interacting. Other asteroids, Earth asteroids, follow paths that occasionally bring them close to our planet. But even these encounters usually pass without incident, silent and distant. There is also the motion of drifting dust. Space, though it appears empty, contains countless microscopic particles fragments from comets, pieces of ancient collisions, and leftovers from early solar formation. These particles scatter sunlight, creating faint glows like the zodiacal light. They move slowly in comparison to planets, forming a delicate inner cloud around the sun, almost like a cosmic haze. On a grander scale, galaxy clusters drift relative to one another as the universe expands. This expansion is not an explosion pushing matter outward, but rather the fabric of space itself, stretching gently in all directions. It is ongoing, constant, and quiet. Galaxies are not flying through space because of a force. They are simply passengers on expanding space-time. It is a motion that happens everywhere at once, like a calm breath inhaled by the universe. Superclusters, the largest known structures in the cosmos, also move. They drift toward regions of slightly higher mass through processes called cosmic flows. One of these regions, known as the Great Attractor, influences the motion of the Milky Way and thousands of other galaxies. The pull is slow, steady, and ancient, another example of how motion shapes everything, even on unimaginable scales. The most subtle motion of all is the motion of space-time itself. Every massive object creates a curvature around it, sculpting the way other objects move. When extremely massive objects accelerate like merging black holes, they create ripples called gravitational waves. These waves stretch and squeeze space as they pass through it, but their effect on Earth is so small that only the most sensitive instruments can detect them. Yet they drift across the universe, carrying information about distant cosmic events. Even gravitational waves, born in moments of enormous power, travel with calm persistence. With all of this motion, rotation, orbits, expansion, drifts, flows, it becomes clear that stillness is rare in the universe. But the motion is never frantic. It is slow, smooth, and graceful, shaped by balances of gravity, energy, and time. This cosmic movement gives structure to everything: the rising and setting of suns, the turning of seasons, the positions of constellations, and the long-term evolution of galaxies. Even on Earth, you feel this motion indirectly. The tides rise and fall because of the moon's orbit. Seasons shift because of Earth's tilt and revolution around the sun. The night sky changes over months and years because of Earth's motion through space. And while you may not feel any of these motions physically, they form the quiet rhythms of life. When you think about this cosmic dance, an unexpected calm arrives. The universe does not rush. It does not panic. It expands leisurely, rotates steadily, and flows gently. Stars glide along their paths like lanterns drifting on a silent river. Galaxies move like clouds across an infinite sky. And planets, including the one beneath you, now travel in smooth arcs that never wobble or stray. This understanding offers a peaceful reminder. You are part of this motion too. You are carried through space on a world that drifts effortlessly, supported by physics that never sleeps. Every breath you take, every moment of rest, happens within a universe that continues its endless, serene journey. As we drift into the final stretch of this quiet cosmic journey, the universe around you feels softer, more familiar, as though its vastness has transformed into something peaceful rather than overwhelming. You've wandered through galaxies, watched stars grow and fade, followed planets through their unending orbits, and listened to the gentle drift of cosmic motion. Now, in this final part, you settle into a reflective space, calm, overlook, where you can rest, breathe, and let the grandness of the cosmos settle around you like a warm blanket. Imagine floating in a place where there is no up or down, where gravity no longer pulls at you, and where sound has no medium to travel through. It is quiet, so quiet that even your own heartbeat feels like part of the background. Ahead of you, stars cluster together in shining knots, each one a sun with its own history, its own potential worlds, and its own unique signature. Behind you, infinite dark stretches outward, a comforting, velvety expanse that holds more mysteries than any one mind could ever grasp. And yet, none of it feels intimidating. Instead, it feels gentle, like a soft lullaby played on the strings of the universe. You start by remembering one of the most relaxing truths of space. Light from distant stars is ancient. When you look at the night sky, you are seeing the universe not as it is now, but as it was thousands, millions, or even billions of years ago. The light from Sirius, the brightest star in the night sky, takes about 8 years to reach Earth. The light from the Andromeda galaxy takes over 2 million years, and the light from some distant galaxies may have traveled more than 10 billion years. That means the light began its journey long before humans existed, long before our sun formed, even before Earth itself solidified from molten rock. This gentle time delay creates a universe filled with ghosts of past beauty stars that may no longer exist, nebulae that may have dispersed, galaxies that may have merged with others. Yet their light continues on, quietly traveling through space at a constant speed, offering us glimpses into long-gone ages. In a way, this makes the night sky a museum of cosmic history, its exhibits arranged not by distance but by time. Starlight is a soft message arriving long after its sender has changed or moved on. Another calming truth is that space is mostly darkness, but not an empty darkness. It is a darkness filled with potential. If you could hold out your hand in space, in that vast, empty region between stars, you would be surrounding yourself with particles so small and so distant from one another that they could drift for years without ever touching anything else. Yet, those particles can become the seeds of future stars and planets. A single grain of dust may one day become part of a nebula, then part of a star, then part of a planet, then perhaps part of a creature looking up at the sky and wondering how everything began. Even black holes, often portrayed as cosmic monsters, have a gentle side when you understand their true nature. A black hole is simply a region of space where gravity is strong enough to prevent even light from escaping. It does not go around devouring stars indiscriminately. Stars can orbit black holes peacefully for billions of years without being drawn in. And the supermassive black hole at the center of our galaxy, Sagittarius *A, sits more than 25,000 light-years away, influencing our sun's orbit but not threatening it in any way. It is a distant, quiet anchor around which the entire Milky Way rotates. Stars themselves offer soothing lessons about patience. A star like our sun lives for about 10 billion years. Right now, it is in the middle of its life, steadily fusing hydrogen into helium to provide the warmth and light that make life on Earth possible. It produces energy in a stable, predictable way, without sudden changes or bursts. This reliability has shaped everything from climate to ecosystems to human history. The life you live is made possible by a star that has remained calm and consistent for billions of years. And when stars end their lives, the processes can be beautiful. Smaller stars, like our sun, swell into red giants and then peel off their outer layers, creating colorful planetary nebula-delicate shells of gas that glow softly as they expand outward. Larger stars explode in supernova, creating heavy elements like gold, iron, and oxygen. Every atom in your body, heavier than hydrogen, was formed inside a star long before the sun existed. In that sense, you are not separate from the universe. You are a continuation of it. You carry the universe within you. You are made of ancient stardust, arranged in a temporary, beautiful pattern that can think, dream, and reflect. As these thoughts settle, you move your attention to galaxies' vast islands of stars, dust, and dark matter. A typical galaxy contains hundreds of billions of stars, and there may be trillions of galaxies in the observable universe. Yet galaxies themselves form clusters that move together, bound by gravity. These clusters form even larger structures called superclusters. And all of these enormous structures are woven into something even larger, the cosmic web. This web, consisting of filaments of galaxies and dark matter, stretches across the universe like a delicate network of glowing threads. It is the largest structure known, yet it is peaceful, balanced by gravity and expansion. Dark matter, which makes up most of the mass in the universe, does not interact directly with light or with ordinary matter except through gravity. This makes it quiet, elusive, and mysterious. And yet its presence is essential. Without dark matter, galaxies would not hold together. Stars would drift apart. The cosmic web would not form. The universe would be a much emptier place. Dark matter is like the invisible foundation that keeps everything gently connected. Dark energy, even more mysterious, causes the expansion of the universe to accelerate. This expansion does not tear things apart at small scales. Solar systems, galaxies, and galaxy clusters remain bound. But on the largest scales, it creates increasing distance between distant galaxies, stretching space itself in a quiet, persistent way. The universe is not just expanding, it is doing so smoothly, without sound, without turbulence, without interruption. And then there is the cosmic background radiation, the soft afterglow left over from the birth of the universe. It is faint, cold, and uniform, filling every corner of the cosmos. It is the oldest light we can see, a gentle whisper from nearly 14 billion years ago. This radiation is not bright or loud. It is a low-temperature glow, only a few degrees above absolute zero, existing everywhere, all at once, as a reminder of the universe's earliest moments. All of these pieces, stars, galaxies, planets, dark matter, cosmic radiation, create a universe that is not chaotic, but balanced, not frightening, but harmonious, not cold, but quietly enduring. As you come to rest in this final reflection, you can imagine yourself floating on the edge of a spiral arm on a tiny planet within a solar system that orbits a modest star. You are part of a galaxy drifting through space, part of a universe expanding gently, part of a tapestry woven from energy, matter, and time. The same forces that shape nebulae and galaxies also shape the atoms in your body. The universe is vast, but you are not separate from it. You belong to it. You grew from it, and you carry its history in every breath and every heartbeat. If you ever feel small, remember that you are made of matter that once glowed inside stars. If you ever feel lost, remember that your body holds atoms older than Earth. And if you ever feel overwhelmed, remember that the universe moves slowly, gently, and patiently. It's like you can move through your own life. In this quiet, cosmic moment, you can take a deep breath, knowing that you are part of a universe built from calmness, persistence, and ancient light. The stars will continue shining. The galaxies will continue drifting. And you can rest, knowing that nothing in the universe is rushed. Everything unfolds exactly as it should, in its own gentle time.